right? Breaking it off without actually punching the hole through that thing. So you want to know the volume of such a thing, because if you're ordering a concrete or something, you are not going to order and say, oh, I need 3 more pounds. So you order another truck for an extra 3 pounds, right, of concrete to be brought in. And you can't just order, yeah, bring me 2 trucks, right, and you can return the rest, because that thing is not going back full of concrete. They're just going to probably dump it on your front lawn and leave, and then you deal with it. Which is actually not bad, because you can just flatten it out, paint it green, and you never have to cut grass again, now that I think of it. That's what I'm doing my backyard. How much is this thing? Yeah, think about it. There's your entrepreneurial idea by me, number 3, right? All you need to do, you concrete the entire backyard, you paint it green if you really like green, but you can do pink grass, you can do anything. You can be creative, and there you go. No more grass cutting ever. It's a one-time expense. Nice. I'm sorry?
Oh yeah, it's gonna crack.
It doesn't matter. You can just.
That's a small fix.
Yeah.
I guess you can just.
You don't need to order a truck for that. You can go to Home Depot and repaint on top. But when you're selling the house, you have the vintage patio in the back, which is green. They can paint any kind. Wow. You're thinking, how hard is it to make a pool? It's just a big hole. Oh, I didn't tell. Oh, so now we're off topic again. Back to the thing. Volume of this 47. Look at the 48, right? It's clearly the top of that architects designed. And why would you want to know the volume of the building? The volume of the building. Yes, very good. Heating and air conditioning. When you're designing the ductwork, volume of the building is the first variable, first parameter that you have to have. Because the amount of air that you have to heat or cool down will determine the size of the ductwork and the strength and size of the units that will push that air around. You can't eyeball that, because if you do that with air conditioning, you are going to produce condensation in the walls, and then that creates water in the walls, which creates mold, and mold creates death. Right? So eventually you as engineer, you're mass murderers. No, I'm serious. Imagine if you just eyeball these things. Look at these vents over there, right? I just hope that they have the good engineer. Otherwise, I'm breeding mold for 20 years and I die, right? This is where you don't have the God complex yet, but you eventually, right, govern who lives and who dies just by not computing the volume correctly. Important stuff. Here's the dome on the bottom. The bullet or awkward umbrella. This is a lot of different things that you can come up with as the application for something like that. Oh, great, the projector died again. So let's compute the skateboard ramp or whatever, motorcycle or bike. Volume. Volume is the top function integrated in the limits that are given to you. So have this, and then the z-axis. This value over here is ln4. This value over here is 2. There will be a value in the back as well, which would be -2. That's good enough. And the shape on the top is e to the -x. So that's your fxy but it only has x in it because it goes this way. So now when you look at this shape, you ask yourselves, okay, so what do I have here? When I draw this on the side, you see that the entire box is from -2 to +2 on the y-axis, and it goes out to ln4 on x-axis. So this is your region R. So volume is the double integral of e to the -x, and then you can say either dx dy or dy dx. So dx dy. X values are from 0 to ln4, and y values are from -2 to 2. Again, make sure that you have pairs, x with x and y with y. So now, the outer integral -2 to 2, the integral of e to the -x is -e to the -x computed from 0 to ln4. And we still have dy to deal with. So this is integral from -2 to 2, and in parentheses I have -e to the -ln4 plus e to the 0, and I still have dy. So now this is equal to integral -2 to 2. The negative will go inside and create one cancel, giving me just -1/4 plus 1 for a total of 3/4. So now I need to integrate -2 to 2, 3/4 dy, which is 3/4 y from -2 to 2. That's 3/4 2 minus -2. So that's 4. The answer is 3. So if the units are, the measurements were in feet, I would be requiring 3 cubic feet of concrete to create that ramp. If the units were in meters, 3 meters cubed, and so on. So whatever the units are, I will be requiring 3 of those units cubed of concrete to create that ramp. Clearly craftsmanship needs to be such that, you know, the curvature is there, which is actually very easy because your edge equation is e to the -x. You can print that and then cut out out of plywood, cut out those curves, put them on the side. When you pour the concrete, you keep right with a piece of wood, and you make sure that you keep that curve there and so on. So whatever way that you engineer the way how to make it later on. But the most important part is how much concrete do you have to order, and that's going to be the volume. So calculating volumes of objects, guys, is extremely important. And next class, which is tomorrow, we are going to deal with general regions. And then eventually, after the exam on Thursday, with polar regions. Volumes that you get from these objects, and then later on from triple integrals, allow you for all types of shapes. Because the reservoir tanks on airplanes, it's not a box, right? They have shape because they fit in the wings, right? So what is how much volume can it, no one is going to allow you as engineer to make a $1 billion prototype so that you can measure how much fuel you can actually fit, and if it's going to take you from point A to point B over the ocean, right? All of these things are calculated first to the goriest detail, and then you make the presentation, i.e. your project, and then your project gets approved, and they get the money, and you get to eat. Otherwise, You go under the bridge. You make a tent and you do not calculate the volume on it. I'll see you tomorrow.